everyone, welcome to my channel. Today we are going to discuss about the operation on sets. Now just like with the numbers, you add them, subtract, multiply and divide. So in the same manner we are going to have some operation on sets, but here we are not going to add them or subtract, multiplication or division, but there are two different kinds of operations in sets that I am going to explain here in this video. So there are two operations. The first one is the intersection and the second one is the union. Okay, I am going to explain you both of this operation along with the Venn diagram. Okay, so if you don't know or have no idea about the Venn diagram, so do visit to my channel, check out in the playlist and you will get their Venn diagram. Okay, now let us start with this topic. So in the operation of the sets, the first one that I am going to start with is the intersection of the two sets. Okay, so what is mean by the intersection of the two sets? So it is very simple. Consider that you will be given with the two sets. Okay, when you will be given with the two sets, you just have to take out the common elements from both of the sets. Okay, so you have to compare them and you have to take out the common elements, and that's it. Okay, that is known as the intersection of the two sets. So let us go by the definition. So it says that suppose you have sets A and set B. Okay, and the set of all common elements of A and B is called as the intersection of the two sets, that is set A and set B. It is denoted by A, this symbol, and B. Okay, so this is read as intersection. Okay, so A intersection B, it is read as A intersection B. Suppose you have a set having elements 1 2 3 4 5 6, and what is this? This is nothing but read as number of elements of set A. Okay, as you can see, there are 6 elements present in this set, so I can write n of A is equal to 6. N of A can be read as number of elements of set A. Okay, this is nothing but 6. Consider the next set having elements 3 6 8 10. Now you can see that there are 4 elements in this set, so I can say that number of elements of set B is equal to 4. Okay, now if you compare both the sets, you can see that I have already underlined 3 and 6 from both of the sets. Okay, that means 3 and 6 are the elements which are common to both of the sets. So I can write A intersection B is equal to 3 comma 6. Okay, so these are the two sets. I can write number of elements of A intersection B is equal to 2. Okay, so basically this is the intersection of the two sets. I hope you understood this topic. This is very interesting and a simple one, and you should know this. Okay, let us move on to the next one. So the next one is the union of the two sets. Now from the word union means collaboration. Okay, it means collaboration. So union of the two sets, in this you are going to take 2 sets or 3 sets, whatever sets you want to take. Okay, and when you take the union, you just have to take the elements of all the sets under each set. Okay, under one set. Now you must remember that the repetition of the elements is not allowed in this chapter. Okay, so let us go by the definition. Consider that you have set A and B. Okay, and the sum or the set of all the elements of A and B is known as the union of the two sets. It is written as A union B. Okay, so this is the symbol for the union, and it is read as A union B. Consider that you have a set elements A, B, C, D. So n of A, that is, you know that there are 4 elements, so I can write n of A is equal to 4. Okay, and here the set B is having J, K, M, N. Now here n of B is equal to again 4 because there are 4 elements. Now as you can see that there are no common elements present in this. So A union B will be A, B, C, D, J, K, M, N. So n of A union B is equal to 8. Okay, so this is the union of the two sets, which is very simple. You just have to take the elements of all the sets under one set, okay, but you have to take care that you do not repeat any element in the set, okay. Now let us take the formula which is giving a relation between the union and the intersection, okay, which is very important because we have learned the different operation, that is union and the intersection. Now let us study the relation between them, okay. So there is one relation here, and this is n of A union B is equal to n of A plus n of B minus n of A intersection B, okay. So basically this formula is only for two sets, okay. If you have two sets, you can take the union, you can take the intersection, and you have n of A and n of B, okay. So basically this is the relation between the intersection and the union of the two sets, okay. This formula is very important for your word problems, okay. Now we are going to verify this formula. So let us take a set where the elements are 1, 2, 3, 5, 7, 9, 11, 13. N of A is equal to 8 because there are 8 elements present in here. Consider the next set, that is set B, having elements 1, 2, 4, 6, 8, 12, 13. N of B is equal to 7, okay. Now as we have got set A and set B, we are going to find out two more things, that is union and the intersection. So the union of the set A and set B will be this, okay. I have just took all the elements of set A and set B under this set, okay. But as you can see here that 1 or 2 is getting repeated, but I have not repeated in this set, okay. So you do not have to repeat any elements while writing the set, okay. So n of A union B will be 12, so there are 12 elements as I have written. N of A union B is equal to 12. Let us find the intersection. So intersection is the common elements. As you can see, 1 and 2 are common in both of the sets, and the element 13 is also common in both of the sets. So A union B will be 1, 2, 13, and n of A union B will be 3, okay. So we have taken all the datas which are required to prove the formula. Now let us take the RHS. RHS is n of A, n of B minus n of A intersection B. We are going to take the RHS. So RHS, let us substitute the value. So n of A is 8, this is 7, and this is 3. So this is nothing but 15. 15 minus 3 is nothing but 12, and 12, as you can see, is nothing but n of A union B, okay. So LHS is equal to RHS, and we have proved this relation, okay. So this formula is very important for your word problems and many of the problems, okay. Now let us move on to the Venn diagram, and we are going to draw the Venn diagram of the union and the intersection sets, okay. Because in my Venn diagram video I have just explained the Venn diagram, how to draw it and how you can draw the various sets in the Venn diagram. But in this I am going to explain you how to draw the Venn diagram for the union as well as for the intersection, okay. So here is one question that is given here, is the Venn diagram. This is the universal set, the whole box is a universal set where you have two sets A and set B, and in the set A you have x, y, z, mn. Mn is the common element which is present in set A and as well as set B, okay. Now S and T does not lie in set A and set B, but it lies in the universal set, okay. And we have to find this 7 answers, okay. That is set A, set B, A union B, universal, A complement, B complement, A union B complement, okay. So let us find the first two, which is set A and set B, which is quite simple, as you can see from the diagram itself, that in the set A you have x, y, z, m, n, okay, or as well as in the set B you have p, q, r, m, n. Now basically this is the region which is common to both of these sets, okay. So while writing this set separately, you have to consider these elements for set A and set B, okay, because this is common to both of the set, okay. So in the set A you have x, y, z, mn, and set B you have p, q, r, mn. Now you can write the union. Okay, so union is nothing but xyz mn and pqr mn, but mn is common, so we have to write it only one time. Okay, now I have found out one more important question which is not asked in this one, so I have written here, which is A intersection B. Now A intersection B means the common elements. Now from the diagram itself you can see the common to both of the sets are M and N. So this is M and N element. Okay, now let us go for the fourth question, which is given as the universal. Now as you can see that from the diagram itself, that in the box there are various elements, that is set A and set B, but there are two more elements S and T which is present in the universal set but not in any of the set, but still we can consider while writing for the universal set. So basically in the universal set that will be X, Y, Z, Mn, P, Q, R, S, T. Okay, again Mn you have to not repeat. Okay, now we are going to write the A complement. So what is A complement? Now as I have already explained you that A complement is nothing but take out the elements of the set A from the universal set, and whatever elements you left in the universal set, that will be the A complement. So as you can see that in the set A, X, Y, Z, Mn is present. So when you eliminate X, Y, Z, Mn from the universal set, you will be left with P, Q, R, S, T. Okay, so this is the A complement. Now let us find the B complement. But as you can see, B complement is P, Q, R, Mn. I will eliminate or remove these elements from the universal set. So P, Q, R, and Mn, I will remove this. So you will be left with X, Y, Z, S and T. Okay, so you just have to remove the elements present in the set B from the universal set, and the leftover elements will be the B complement. Okay, now let us find the last one, which is A union B complement. We will perform the same operation. Now as you can see that in the A union B set you have X, Y, Z, P, Q, R, M, N. Okay, so I am going to eliminate this all elements from the universal set. So when you eliminate or remove these elements from the universal set, you will be left with only S and T. So S and T will be the A union B complement set. Okay, so I hope you understood this question. This question is very important, and if you know your basics well, this will be very easy for you. Okay, now let us move on to the next one, that is A union B. N of A union B is given as 29, N of A 15, N of A intersection B is given as 7. We have to find N of B. Okay, now these are the some datas which are given and we have to find the N of B, but we can find this using the relation given between the union as well as the intersection. Okay, so let us write the formula. So this is the formula. Okay, now we have to find the value of N of B. So what is value of N of B? N of B can be found out as, you can take the minus here as plus, and you can take this N of A on the left hand side. So this will become N of B will be equal to N of A union B plus N of A intersection B minus N of A. Okay, so I have just moved some elements on the left side. Now when you substitute the values, you will get 29 plus 7 minus 15, that will give you 21. So N of B here comes at 21. So the number of elements present in the set A is equal to 21. Okay, now let us move on to the next one, which is the last question of this video. It is a very simple one, so let us read the question. It is given here that in a hostel there are 125 students. So there are total 125 students present in a hostel, out of which 80 drink tea, 60 drink coffee and 20 drink both tea and coffee. Okay, so 80 drink tea, 60 drink coffee, 20 drink tea and coffee both. We have to find the number of the students who do not drink tea or coffee. So we have to find the number of students who do not drink tea or coffee. Okay, but total number of the students are 125. Okay, now as the total number of the student is 125, so we can consider 125 as the universal set. Okay, basically universals, in the universal set everyone lies, every student lies who drink tea, who drink coffee, who drink both, and who do not drink tea or coffee. Okay, so basically 125 is the universal set. So let U be the universal set of the total number of the students, A be the set of the students who drink tea. Okay, we are going to consider two sets because there are two different things are given here, tea and coffee. Okay, and for both of them, both is very simple. We will take the intersection. Intersection means the students who are common to the tea as well as for the coffee. Okay, and let B be the set of the students who drink coffee. Okay, so this is n of U is equal to 125, n of A is equal to 80, n of B is equal to 60. So these are the students who drink tea, these are the students who drink coffee, and this is the total number of the students present in a hostel. Now, number of the students who drink both tea and coffee, so that will lie in set A as well as in set B. So I have taken A intersection B. So n of A intersection B will be equal to 20. Okay, so there are 20 students who drink both tea as well as coffee. Now we will take this formula because this is the only relation we have for the intersection as well as the union. Okay, now we will substitute the formula and we will get the value as 120. So we get n of A union B as 120. Okay, now n of A union B means that there are students who drink tea, there are students who drink coffee, and there are students who drink both tea and coffee. That lies in 120. Okay, that lies in 120. But as you know that we have total number of the students as 125. So basically there are 120 students who drink tea, coffee, or both of them. Okay, so when you subtract them, that is 125 minus 120, you get 5 students. You get 5 students who do not drink anything, that is no tea, no coffee. Okay, so here we got the number of the students who do not drink tea or coffee is equal to 125 minus 120 is equal to 5. So there are basically 5 students who do not drink anything, that is tea or coffee. Okay, so I hope you understood this video. This is very important for your chapter sets, and also share it with your friends and do subscribe to my channel, and also comment that you like this video, and thank you so much for watching this video.